Maintenance. This is a good definition for maintenance, the modification of products after delivery to correct faults, improve performance, or add features, other attributes, or to adapt it to a new environment. And definitely maintenance is a privilege. It's not the kind of thing that you should think of lightly, because if you have successful products, they are going to need maintenance. And in fact, they're going to need a lot of maintenance. Any successful product is going to require something to upkeep it. Software is more of a living thing than a finalized thing. And environments change all the time. Libraries, dependencies, user operating systems change all the time. You're just going to have to update your software to continue getting it to work properly. It is an essential aspect of software development in all of the same ways that the other phases of software development are essential. You cannot skip it. If you try to skip it, what that actually means is that you've done a really terrible job of doing it. And most of the cost of your software system, especially if it's successful for years and years, are going to end up in the maintenance phase. Fred Brooks in the Mythical Man Month says up to 90% of the cost of a typical system are going to be in maintenance. I don't know if it's quite that much anymore for a lot of software systems, but it is still very expensive when you compare the overall development cost to the maintenance cost of successful software systems. One way to think about it is to look at software that's been around for decades, like Microsoft Word. How much money do you think they have spent after the initial release of Microsoft Word adapting it and rewriting it and rebuilding it and maintaining it? Because it's quite a bit more than the initial development was, for sure. There are, of course, different types of maintenance. Perfective maintenance is essentially responding to users' desires for improved functionality. Corrective maintenance, bug fixing, essentially. You want to correct all the errors that have been found by users after you deploy it. And I don't care how good your testing system is, when you deploy to thousands and thousands of users, you're going to find additional bugs. Adaptive maintenance is responding to environmental changes. So that could include maybe adding new features depending upon what is added, what changed in the environment. A good example of this would be something like the dark mode that was added to macOS the last couple of years. A lot of software that had already been released suddenly had to adapt to include a dark mode to make it look as though it was maintaining parity with all of the competing products that were being added to the market. Preventative maintenance is the ability to ensure future maintainability, future functionality of the system. Generally, this is not going to be visible to end users, but it is the kind of thing that a strong organization will take the time and money to do so that they are saving long-term costs. Now, these different types of maintenance, these definitions are actually part of a standard, the ISO standard for maintenance. And I think they're a really good way to differentiate the ways that you might approach maintenance. You don't have to do all of these every time you do any sort of maintenance. You can be much more targeted and focus on one thing at a time, and that may make your maintenance both easier to do and less expensive. Maintenance happens in stages in the same way that requirements analysis and identification and specification are the various stages of the requirements engineering process. You have different stages of maintenance as well. Naive developers just sort of think of maintenance as just the second stage here, just evolution. That's a mistake. There's a lot more to maintenance than just the evolution of the software to to add new features or remove unneeded features, that sort of thing. So the initial developmental stage where you're building the software, especially when you're just about to release the software, you're really doing minimal maintenance. You haven't actually begun the maintenance phase yet. Then you move into what most people think of as the end game, the last piece of the process. That's the evolutionary maintenance, where the product has been deployed and you may be adding new features, but you're really not doing much more than that. Servicing is when you've decided, okay, this is feature complete, we're not adding any more new features, but it's still being actively used by our end users, and so we want to make sure that the features that are there are still working properly and is still effective. Finally, you have the phase out and close down stages. Essentially, this is when you decide the product has reached its end of life and you are getting ready to take it out of service. So you have a kill date. That's the phase out stage. You start notifying users, You may not be doing the same kind of servicing, but you may still have some things that you need to do in terms of making sure that the product is still useful for users who are actively using it. And in the phase-out phase, you may actually add new features to allow consumers, I should say, to move to other products that that may be competing products or continuity type products. It sort of depends on the product that you're actually putting into phase out. If it's something that you're planning on internally replacing with another one of your own products, then you may have a transitional feature that allows somebody to export their data from your product and import it into the new product that your company has created. And then the last phase is the close down phase, where this is the actual process of taking the product offline and ensuring that you've disposed of all the assets as you may be required by law. Changing deployed software is not easy. Deployed software requires a lot more knowledge and experience to change than any kind of a pre-release software, and the stakes are much, much higher. So one of the big problems that people don't generally see in maintenance, or most non-technical folks don't generally see, is that you have to understand the whole product, not just like the internal aspirations of what you wanted the product to be, but also how the product is actually being used by stakeholders. What sorts of things do stakeholders like about the product? And this involves quite a bit of understanding, general knowledge of what the software is, how it relates to the environment, how stakeholders relate to it, understanding where in the system changes need to be made so that you can affect the maintenance that you're interested in doing, adding new features, for example. And then also having an in-depth knowledge of the parts and history of how things have been modified or corrected or changed as the product has aged. All of this is not easy to do, and it's often institutional knowledge that ends up helping you out here. So like if you have developers who've been with the product for a while, that the maintenance staff can either interact with, or that you could transition into maintenance with the maintenance staff, your product is probably going to be easier to maintain and be more successful in its maintenance phase than your competitors' products would be. Here are some of the problems that you may encounter over time as you maintain software. The first of these is kind of counterintuitive, but productivity is going to decrease for your maintenance staff over time. And the maintenance costs are going to increase. And a lot of that is because of the stuff we just talked about previously, the difficulty of changing deployed software. All of this knowledge just grows. Having an understanding of the history and the sorts of features that have affected the consumer base, how the environment has changed, all of that sort of stuff, it just grows in terms of how much of it you need to understand. And so therefore, understanding and being careful in making changes causes your productivity to decrease and your costs to increase. It's also worth pointing out that the code is going to be harder to understand. Essentially, you're no longer interested in maintaining the system so that every single line of code is as perfect as it was when it was first created. Sometimes new paradigms, new frameworks, new methods are developed after a system has been deployed. And so you are left with people who have to work in something that is now seen as suboptimal and may not even really be taught to newer developers. Certainly this is problematic with COBOL systems. I know that New Jersey in the last month or so had a major problem with their unemployment software because it was all written in COBOL and it was being overwhelmed by the millions of people who were trying to file for unemployment benefits. And this is why it's so expensive to fix that kind of software. The code has been written in a language that is not commonly used, using paradigms that are not commonly taught. And so the code and the documentation is seriously out of date. The code is just hard to understand. Your dependencies may also become out of date or have security problems that you would now be responsible for fixing or working around. Especially with web frameworks, there's a very short shelf life for those. And it seems like if you've developed and deployed any kind of web software, just a couple of years after you deploy it, all of a sudden there's a new framework, a new development mechanism that you probably would like to take advantage of, but you can't because your whole application has been built on some other framework. And you have to be aware of what are the limitations of that framework so that you can maintain the software in a way that would allow for users to continue to use it and for your organization to continue to monetize it. The number of errors end up being increasing over time. This is mostly because things start failing, right? Maintenance is necessary to address some of the problems that we just talked about because they'll be reported as errors. And this makes sometimes the fixing of these errors, it makes the original design corrupt. It's not the kind of thing that you're going to be able to maintain indefinitely, especially when so much of the environment around your application is changing as well. So you may have had an original vision of how you thought this would work that is now not necessarily wrong at the time that it was created, but now wrong relative to the environment in which it was deployed. So all of these are the kinds of problems you should expect when you have successful software projects as a part of your maintenance lifecycle. And normally we would do a pretty extensive activity where you would get with your project groups, identify the likely problems in your deployed product, and talk about the kinds of solutions you might want to consider during maintenance. This is the kind of thing where we would share some of these solutions in class. I would very strongly encourage you to do this with your project groups the next time you have a project meeting, because it is a very useful tool when you start thinking about the kinds of things to expect in the maintenance phase. You have an actual product, you have an actual problem, and you've got people who are familiar with this enough to begin discussing the sorts of things that you may have to do over time as the project ages. The more you do this, even in a thought experiment fashion, the better off you'll be when you move into an environment where all of a sudden you're kind of facing this stuff from the very beginning. So we'll talk a little bit about the maintenance process and some of the things that you would need to do in order to better understand the programs that you're maintaining in the next section, and then move on to software evolution.